Hello and welcome to section 2.1. Today we're going to talk about the derivative, what it is, and how it relates to the tangent line problem. So I figure we should just get started right away. And to get started, I want to talk about what a tangent line is. Many people have some misconceptions about what a tangent line is. A lot of people think it's just a line that touches a function at only one point. But that's not necessarily the definition of a tangent line. Right? Sometimes that may be true. But to be precise, a tangent line is the line passing through a point of a function with the same slope as that function. So, for example, let's draw a couple. Let's say we have this function and we want to draw the tangent line at that point. Well, for this particular function, the tangent line does only touch the function at one point. Okay, so that's where a lot of people get confused that maybe that's the definition. It's the line that only touches at one point. Okay, but that's not necessarily true. With this function, we are touching that point, and you have the same slope as that point. But let's say we draw a function like this. Let's do it in green. And we want to draw a tangent line right there. Okay, so the tangent line right there is going to go through that point, and it's going to have the same slope as that point. But as you can see, this line touches the function in more than one point. It touches here, it also touches here. And to even further draw your definition away as a line that touches only one point, what if I drew the tangent line of a line at this particular point? Our definition says that it's the line that goes through a point of a function and has the same slope as that point. Well, the tangent line in this particular case would be the exact same line. So I don't want you to think that a tangent line is just a line that touches at only one point. But think of a tangent line as the line passing through a point of a function with the same slope as that function. And that's the key, the same slope of that function. Because slope really tells us a lot about a function. So, what we're going to do now is we're going to define what a derivative is. And I'm going to just bring a fresh sheet of paper in here, and we're going to draw it. And it's going to be a fairly large picture here. And when you draw this, make it a fairly large picture as well. Alright, so here's my picture. We'll call this x-axis and this y-axis. And we have a function. Let's say that looks like this. Y equals f of x. Okay, so the derivative is the process of finding the slope of a function at a particular point. Alright, and let's write that down. Maybe we'll write it down here. Finding the slope of a function at a particular point. So that's what we're doing with this particular function. All right, that's what a derivative is. So for instance, let's say that we want to find the derivative, or in other words, we want to find the slope at C. We want to know the slope at C. And so the method to finding the slope at C was to pick a point not at C, right? And we'll call this C plus delta x. And the reason we're calling it C plus delta x is that this distance is our change in x. All right, so we have c, we add delta x to it to get c plus delta x. So we get then 2 points on our function. We get f of c, and we also get f of c plus delta x. Okay, really make sure that that's clear to you. We're trying to find the slope at c. In order to do so, we're taking another point, not on c, that's a certain distance away. It's delta x away. And then what we're going to do is we're going to find the slope in between those 2 points. Okay, so we're going to find that slope. So the slope of that particular line is just going to be like any other slope that you've done before. It's going to be y2 minus y1 divided by x2 minus x1. So that is the slope of that red line. Okay, so again, y2 minus y1, so it's this distance. Let me draw it in a different color here. Okay, this distance here is y2 minus y1, so f of c plus delta x minus f of c. And this distance here is c plus delta x minus c. Okay, it's just the slope of that line. And what we're going to do, obviously, is that this slope is not the exact slope of c. So what we want to do is we want to move this point closer. We want to change the distance between our 2 points, and we want to make it smaller. And so essentially what we're trying to do is we're trying to make this distance as close to 0 as possible to give us the best representation of what the slope will be for this function. So here's what it's going to look like. We are going to take this function and we're going to take the limit of it as delta x approaches 0. And remember, delta x is the distance between these two functions. So we want these 2 points, excuse me. We want the distance between those 2 points to be as close to 0 as possible so that we can get the best answer for our slope. So a derivative is the limit as delta x approaches 0 of f of c plus delta x minus f of c over c plus delta x minus c. And so this is the slope at c. And obviously what we can do is we can reduce the bottom a little bit. Okay, you can see that we have c plus delta x minus c. The c's will go away. And so we write it as f prime of c. So the slope at c of the function is equal to the limit as delta x approaches 0 of f of c plus delta x minus f of c over delta x. And so that is the definition of a derivative. The derivative at c for a function is the limit as delta x approaches 0 of f of c plus delta x minus f of c over delta x. So anytime you're asked to find the slope of a function, you can do this particular thing. And really, so a derivative is just a special type of limit. All right? And this limit, this part right here, that's called a difference quotient. Taking two differences and dividing them. So you'll see, find the difference quotient of this. That's what that's saying. Okay, find the slope of the function as you move the 2 points infinitely close together. Okay, so that's a derivative. I do want to talk about one more thing in this video. This is the derivative at a particular point. All right, this is the derivative at c. You could find the derivative in general of a function, which means essentially that the derivative at any value x is really the same thing. The limit as delta x approaches 0, f of x plus delta x minus f of x over delta x. Okay, this particular one that we wrote over here is at a particular point c. This definition of a derivative is at any point x, the slope is whatever we get here. Okay, so that's it for this video. There'll be a couple more videos in this section, a few examples of how to use this formula, and then what it's useful for. I hope you have a fantastic evening.